I did was I substituted into b to the fifth. So b to the fifth equals ax quantity to the fifth. Okay. Somebody tell me, what's the next thing that they did to be able to show this proof?
By multiplication?
Yeah, we just used the power of a product rule. We could just say by multiplication. Sure, multiplication's nice. And or what did that become?
A to the power fifth, x to the power fifth.
A5, x5. Okay. There may or may not have been a hint that could be helpful at this point. Okay. So what do we know about a to the fifth? A cubed times x, a squared. Good. So we're going to say that this is equal to a cubed times a squared x to the fifth, right, guys? And that's just factoring, right, guys? I mean, literally, when you pull apart numbers, okay, or variables like that, that's just factoring. Like, remember, for those of you guys that suffered in Calc 2, you had to break off the sine or the cosine to be able to do the correct u substitution. This is exactly what we're doing. We're factoring off an a cubed, okay? Or maybe you don't remember that because it was a horrific memory and you repressed it. Sorry. So this is factoring. And then I think this might be it. Because don't we see that there's a factor of a cubed in there? What's the only other thing that we really need to do?
A cube m closure.
A squared x to the fifth is equal to what? M or
M.
something like that. Nice. So we can say this is a cubed m, where m is an integer. Okay? This whole thing right here is just multiplication. Okay? Literally, it's just 2a's and 5x's being multiplied, so it just becomes a new variable. We're going to call it n. Okay? That's closure. And we're done, right, guys? There's not a lot of algebra going on here, okay? So, but again, it's a little bit sneaky because most of the time we're so used to multiplying things. We're not used to factoring off things, okay? And that's what we do in discrete math. We look for sneaky ways to factor things off, or the one trick where we might have to say like 7 is 6 plus 1. We just pull things out like that, okay? All right, so what we can say is that thus, b to the fifth is equal to a cubed m and contains a factor of a cubed. Therefore, thus, hence, whence, a cubed divides b to the fifth by the definition of divisibility. So, let me give you guys a few moments to look at that, digest it. Hopefully it doesn't come back up. But are there any questions I can answer for you guys about divisibility proofs? Okay. For most students, from my experience, the hardest thing for students to remember is where to substitute into. So remember, always substitute onto the right-hand side, okay, of what it is that you're trying to prove. The rest of it should be good. Okay, Fred, go ahead, sir.
So like, you don't even need to worry about the a cubed.
No, because that's what we're trying to show eventually.
Okay.
And if you do all your algebra correctly, you're going to see that it does contain that fact.
So the only thing you really need to look at is that far right.
That's exactly right. The rightmost thing in that line. Okay? That might be the most useful thing. Okay? Other questions before I give you guys maybe a hint or two about the assignment? Okay. So let me pull up assignment 4 really quickly because there was one question I wanted to make sure I gave you guys a hint on. And Greg asked me for this before class. Greg asked, not Greg did. Assignment 4. Yes, I want to open it. All right. Greg, correct me if I'm wrong. It was problem 3. Is that correct, sir?
That's it?
Okay. So. No, that's not right. Okay. So, can everybody see this? Damn it. I'm trying to make it so everyone can see it. I'm not doing a good job here.
You can scroll and scroll up on the map.
Oh, here it is. No, I'm sorry, Don. I was listening to you, but there we go. Okay. So basically, this is the problem that I want to show you guys like a little bit of a hint on. Okay, it's similar to what we did in class, but there's a little bit more algebra involved. If m is any odd integer, then -1 to the n is equal to -1, which you guys already know. Okay. So I'm going to skip down to the point where you guys have defined all the variables. and you get to the substitution step. So you guys, like, you're gonna do all the 1, okay? And you guys are gonna do substitution. And you guys are gonna eventually say that -1 to the m is equal to -1 to the, like, 2x plus 1, okay? And Greg, I'm assuming that's where you got to, and you're like, well, F this, I'm not gonna use like any logarithms or anything like that.
That's
because-
right.
Oh, yeah, and you probably were starting to beat your head up against the wall because you didn't wanna do that, right? Okay. Let me give you guys a suggestion for this, okay? For those of you guys that have recently suffered through Calc 2, you guys might remember that you could factor off one of these -1s and rewrite this as -1 times -1 to the 2x. Okay? So that's -1 the first. Does that make sense, Greg? Just- Right.
Yeah, I
Guys.
actually thought about that too, but I didn't think you could keep it that way because
Oh,
the
no.
definition is 2x or 2n or whatever.
Right, yeah, you can definitely do that, okay? So you were thinking in the right way, okay? Guys, didn't we already show in class that this is equal to 1? Okay, so all you guys have to do is just look at the proof we did in class, show that this equals 1, and you're done, okay? So show that equals 1, use in class proof, okay? And then obviously close it out. So Greg, does that help out a little bit? It's like, duh, now I got it. So, yeah. But sometimes you just need a little help in to be able to do this. Okay. Is there anything else on the assignment that might look like it's tricky? In fact, number 5 we did, didn't we, in class? So nobody better get that one wrong. Boy, that would be embarrassing. What's that?
I just think, yeah, I redid it, I didn't know.
Oh, yeah, just do it. I mean, just do it again, guys. It never hurts to
We
get
did
some
number
free
1 in
points.
class, too.
We did number 1 in class?
Yeah.
Jeez.
That's fine.
Did we do number 2, 3, 4, 5, 6, 7? Okay. So, let me show you guys number 7 real quick, because it's not that difficult, but I just want to show you guys like a hint on that one. It says the opposite reciprocal of a non-zero integer is rational. Okay. So for number 7, okay. So you guys are going to define, let's just say x is going to be some sort of rational number. So x is rational, which means x is equal to, what is it, a over b, where we would have to say a and b are non-zero. And the reason we say a and b are non-zero is because it says that the opposite reciprocal of a non-zero integer. That means the numerator nor the denominator cannot be equal to 0. Okay, so does that make sense, guys? This is why both of them are in this one instance. Okay? So, now there's no substitution. Okay? So this is just the definition of opposite reciprocal is going to be equal to 1 over x, or negative 1 over x. And guys, what is negative 1 over x equal to with respect to a over b? Negative b over a, right? Nice. And then negative b over a, isn't that really the same thing as like c over a, since the opposite of b is just some other integer c? Okay? That's really like a closure step right there. Okay? So that's literally the entire proof, like the algebra for that proof. So I always get students that get really, really confused on this one, and it's literally only meant to be like a step or two. Okay? So when you guys go home, make sure you use this hint to be able to help you guys. And obviously you're going to write a little more formal than this. Okay? This is just like the bare bones stuff that you need. Okay? Was there anything else that you guys might look at and looks like it's going to be difficult for you guys to work through? I think those might be the only 2 that we don't have like an explicit example for. Okay? Well, I guess it would help if you could see the first 4, but then again, we already did the first 4 in class, so it doesn't matter. Okay, so if you need some help with stuff, stick around so I can help you guys out with whatever you need, okay, at least in the street math. If you guys are going to get here a few minutes early next time, I'll be happy to help you guys out there. Okay. All right, guys, have a good week, good weekend. Only 2/3 of the class left to go. Yay.
When's this